Greetings, I'm Adityagandhi and today I'm going to be presenting Elasticache, which is my autoscaling distributed key value storage system. The idea of implementing Raft came because monolithic architecture has been outdated since quite some time. Distributed architecture is the thing right now, and in order to enforce it, we need a system that ensures proper scalability and reliability. And thus, Raft consensus algorithm was the first thing that came into my mind, and thus I decided to implement a system on the basis of it. We'll be looking into the details of it and how it is better than Paxos in the upcoming slides. Raft consensus algorithm has actually been implemented in many real-time systems. Now, of course, they are going to be very different from my project since they are going to be implementing it on a much grander scale, intended for real-time customers. Their main goal is to provide scalable, reliable service to customers. But the base idea remains the same since they're using Raft algorithm as well. Now, TIKV, as we see on the left side, has been mainly used in order to enforce asset properties, and it is just acting like a database. But for many servers present worldwide, console is going to be much closer to our project, but it is mainly intended for health services. Thus, the base idea of my project is to implement Raft consensus algorithm for the purpose of which I'm going to use Golang or Go. It is a new language to me, which is quite in usage right now, and it is actually a bit controversial because of its whole syntax and format, which interested me more. It is primarily used for network and system structure, and thus I felt it would be a perfect opportunity to try something new and gain some more experience in the field. Now, my system is not just a implementation of Raft algorithm. I aim to implement it in order to store particular values to provide a demo of it, and lastly, utilize Dockerized containers in order to virtually host it as well with the help of AWS Lambda. Thus, I aim to utilize a multitude of skill set in order to execute this whole project. How Raft is organized is on the basis of the master-slave architecture, which we are going to look at next. It is actually quite reliable because instead of preferring any particular strategy, it uses randomized timeouts assigned to its nodes in order to select a leader. Thus, there is no particular mechanism which can be leveraged by malicious users. Hence, the system is more tolerable as compared to the rest out there. And before we take a look at Raft consensus algorithm, we should be taking a look at its predecessor, that is Paxos, and what was wrong with it, that it went out of existence and instead Raft is being implemented and preferred right now. So the problem with Paxos was it was giving a ranking to all of the servers present in the system. And thus, if someone wanted to overtake the whole system, say of a few hundreds of servers, all they had to do was take control over the few top 20 or 30 servers because they would be redirecting every other server as well. Thus, take control of the few top servers and you have control over the entire system, or at the very least, you can stop its execution, thus executing a DOS attack of some form. Now, Raft relies primarily on two methods, that is request host and append entries RPC method. Both these methods implement two core functionalities of Raft algorithm. The request vote RPC method is used when any system or like server wants to come into power. It will transition into the candidate stage and use this method in order to send votes. When a particular leader has been designated and elected by the majority of the system, the request vote RPC method will not be in use. Instead, the append entries RPC method would be used. Here, the server can send the log entries which it received from the client, or can send empty log entries which serve as heartbeats in order to let the entire system know that the leader is up and running. Hence, thus, there is no need to designate a new leader. Sending an empty heartbeat message to all the other server also resets their election timeout periods. Thus, the servers won't be running out of time now. Thus, they won't transition into the candidate stage. Thus, a new election won't be triggered. A new election is triggered when a particular server's time runs out, and thus it transitions into the candidate stage and will start hosting an election of its own. As I was mentioning before, each server has a timeout period. When the time of that particular server ends, it will transition into a candidate stage, thus start an election. In order to make the process more fair, randomized timeouts are being assigned to each server. Now, in the practical system, the timeouts between 150 to 300 milliseconds would be assigned to each server. This assures the system that no more than 2 or 3 servers would be timing out at the same time. Hence, not many nodes would be rushing in the election hoping to become the leader. This ensures that the candidate who actually aspires to be the leader can gain the majority of the votes and thus actually transition into the leader from there on. One disadvantage of the raft algorithm is present here, that if a server who is in the candidate stage does not gain the majority of the votes, then that whole election term is considered useless. No work is done in that particular period and it will be discarded. Thus, we take a look at all the three major states that a server can have here, that is leader, follower, and candidate. First, we look at the leader, who is responsible for getting all the requests from the client side, storing them, and then imparting or like replicating the same requests and commands on the followers. The leader is actually doing the work of directing the whole system. Each leader is elected for a particular term. After that end of that particular term, a new leader will be elected. In order to become a leader, a server has to gain the majority of the votes. That is, for example, see there are n servers present in the whole system, then the leader has to gain more than n by 2 number of votes in order to become the leader. This ensures reliability in the whole system. Now, the follower is rather simple. The follower's work is just to execute the commands as the leader is passing on to it. One more function of the follower is to start its own timer and wait for it to time out in order to transition into the candidate stage, and thus it can start its own election. The candidate, as I explained before, is just going to do the task of hosting the election and hoping to become the leader. Thus, if we just take a look at the process, every server starts as a follower. Once any particular server times out, it transitions into the candidate stage, starts an election, and requests votes from the rest of these servers. If it is successful, it will transition into the leader stage, else the entire term is discarded for that particular server and no leader would be elected in that particular term. Once a candidate has been transitioned into a leader stage, it will remain as the leader just for that particular term. It will keep on sending heartbeat messages to all of these servers to let them know the leader is still up. They're still going to receive commands. The system is still up and running. Thus, it will receive also commands from the client side, which it will be executing and passing on to the other servers for them to replicate and execute as well. Thus, the leader is actually doing the whole task of directing the whole system, but the client is just passing the commands from itself to the leader. I learned a multitude of skills while working on this project. And of course, those skills were the basics of the workings of distributed system, shell scripting for deployment of all the Dockerized containers and hosting the entire system in virtual servers. Front-end part I am quite familiar with, but integrating that and making the whole system work was quite a bit of a challenge as well. Testing the system was a whole lot more troublesome than I actually expected, and of course, this revised and helped me learn new concepts of Golang as well. I believe this project developed my L2 skills to the maximum. One particular and interesting example is you have to set the time of each server before it starts requesting votes and transition into the candidate stage to about a time period, a random time period between 150 to 300 milliseconds. I did the same. But then I found out that the leader was not getting enough time in order to replicate the logs to all the followers who might not be quite up to date. It was not getting the chance to pass on the commands. Each time a new election would be triggered. Thus, the actual work was not being done. Now after like debugging and bashing my head for some time, I asked some professionals in this field who are quite familiar with the concept of distributed system. I reached out to them through LinkedIn, people I know as well, and I found out that the main reason behind this was the latency of my system is quite more as compared to industrialized servers. Thus, that is causing my system to be lagging a bit behind, and thus I'm not getting any actual work done. Thus, I actually had to set up the time periods of all these servers and of all other values as well, and like multiply them by a factor of 10 in order to actually view the implementation as well and accurately execute it. As I mentioned before, the whole idea of this project is based on L3 skills that to get engaged in something that is quite trending in the IT industry right now to stay relevant. And I actually wanted to switch from front-end work because I observed that front-end work can now be easily done by chatbots and LLMs. Thus, to stay relevant in the industry, I decided to shift to its other aspect, that is back-end work, and decided why not make a whole full stack project and get to know how actually a system works. Why I actually want to host this project on Docker containers and like virtualized systems is that cloud and DevOps is quite on rise right now, and that is what senior engineers are actually engaging in rather than building the actual system. Thus, it was motivated by these two factors that I decided to develop my L3 skills in this region. One thing that is, if a new leader comes into play, he has to copy all of his logs to all the other followers to ensure a consistent state. Now, to actually gauge where the follower is, a linear method is being used. A binary search method could be used, but the problem with that is if a particular term is present in the leader and not in the follower or vice versa, then it would be actually going into the time complexities of n into log n in the worst case, which is actually quite bad as compared to the linear case. Thus, in this case, I believe some sort of custom rules have to be set up which requires further testing and debugging in order to make an actual optimal system, which would be my future goal. Following is roughly a task-based breakdown of all the important functions that I executed in this whole project work. These are some of the references I referred to while making this project. More can be found in the detailed report. And I also apologize if I was interrupting a bit when speaking because I do have a stammer. Have a great day.